There are 5 primary things you'll be learning as part of this. First, I'll show you the Kubernetes architecture overview at a very high level. So once you get comfortable with it, we will next look at the Kubernetes master component. Then after, we will look at the Kubernetes worker node. After that, we will combine this master node and the worker nodes together to form the complete Kubernetes architecture. Then you will get a clear picture of Kubernetes architecture. Finally, we will review the terminology we used as part of this discussion. So, these are the primary objectives of this video. And now, let's get started with first thing in this video, and that is Kubernetes at a very high level. Let's imagine a typical team structure where there will be one or more team members. So to provide a direction and manage to this team, we have a manager. All of the team members works together on the common goal, and the team manager is the one who coordinates various activities and supervises the entire team. And Kubernetes architecture works in the similar way. Like any other distributed application, Kubernetes architecture consists of at least one master node and multiple worker compute nodes. For simplicity purpose, we have a one master and 3 worker nodes here. But in reality, there will be more than one master server for high availability and fault tolerance purpose. And worker nodes can go up to hundreds or even thousands as well. Currently, Kubernetes supports up to 5,000 worker nodes per cluster. So let's discuss some of the very basic and most common components of Kubernetes cluster here. First, let's start with Kubernetes worker node. The worker nodes are nothing but a virtual machines or a physical servers running within your data center, or it could be a VM in cloud. These are the workhorses of a Kubernetes cluster. They expose the underlying compute, networking, and storage resources to the applications. So all these nodes join together to form a cluster with providers, fault tolerance, and replication. By the way, don't get confused if someone calls these nodes as minions, because in the early days of Kubernetes, it is called as minions. I guess we hardly see anyone calling with that name now. But for the rest of the course, we'll stick with calling it as worker node or just a node. Next, now moving on to the pods. I guess this is one of the most used terms in Kubernetes. So what is a pod? This is basically a scheduling unit in Kubernetes. So to help you better understand, you can think pod as VM in virtualization world. In Kubernetes world, we have a pod. Each pod consists of one or more containers. In most cases, there will be one container. There are scenarios where you need to run 2 or more dependent containers together within a pod, where one container will be helping to another container. So with the help of pods, we can deploy multiple dependent containers together. So this pod acts as a wrapper around these containers. We interact and manage containers through pod. Next, moving on to containers. I guess most of you are already familiar with containers by now. In case if you have jumped directly right here, don't worry. Containers are a runtime environment for containerized applications. You run container applications inside the containers. These containers resides inside the pod. Also remember that containers are designed to run microservices. Containers are not ideal for running monolithic applications. And finally, the master. Master is responsible for managing whole cluster. It monitors the health check of these nodes. It stores the information about the members of the cluster and its configuration inside the master. So when worker node fails, it moves the workload from failed node to another healthy worker node. Kubernetes master is responsible for scheduling, provisioning, controlling, and exposing API to the clients. So that's about the Kubernetes master at a high level. So this is a very basic architecture of Kubernetes, where you have a master and worker nodes, pods, and containers. One thing to remember to avoid the confusion here is, So you have a worker node. Inside the worker nodes, you have a pods. Inside these pods, you have containers. If you remember that relationship, that will be easy. And also one more thing, inside these pods can have one or more containers. So that's about the basic architecture of Kubernetes. And now it's time to go a little bit in depth. First, let's look at the Kubernetes master, and we'll see what are the 4 components that makes up the Kubernetes master and how we interact with Kubernetes master. So coming to the Kubernetes master is responsible for managing the entire cluster. It coordinates all the activities inside the cluster and communicates with the worker nodes to keep Kubernetes and your applications running. So when you install Kubernetes on your system, there are 4 primary components of Kubernetes master will get installed. First, the API server. API server is kind of a gatekeeper for entire cluster. If you want to create, delete, update, or even display any Kubernetes object, it has to go through that API. API server validates and configures the API objects such as pods, services, replication controllers, and deployments. And it is responsible for exposing various APIs. It exposes APIs for almost every operation. So how do we interact with this API? Using a tool called kubectl. It is also called with various names such as kubecontrol and also kubectl. It is a very tiny Go language binary. It basically talks to the API server to perform any operations that we issue from the command line. So that's about the API server. Next comes the scheduler. As you may guess, scheduler is responsible for physically scheduling pods across multiple nodes. So depending upon the constraints that you mentioned in configuration file, scheduler schedules these pods accordingly. For example, if you mention CPU has 1 core, memory is 10 gig, the disk type is SSD, and other affinity or other constraints that you may want to declare in the artifact. So once we pass this artifact to the API server, the scheduler will look for the appropriate nodes that meets this criteria and will schedule the pods accordingly. So that's about the scheduler. Now moving on to the next component, which is control manager. Actually, there are 4 controllers behind the control manager. They are node controller, replication controller, endpoint controller, and service account and token controllers. So at a high level, these controllers are responsible for overall health of entire cluster. It ensures that nodes are up and running all the times and correct number of pods are running as mentioned in the spec file. So that's about the control manager. Finally, etcd. At the bottom, you're seeing what is called as etcd. etcd is a distributed key value lightweight database. It is developed by CoreOS. It is a very popular distributed key value database. So etcd in Kubernetes is going to be the central database to store current cluster state at any point of time. Any component of Kubernetes can query etcd to understand the state of the cluster. So this is going to be the single source of truth for all the nodes, all the components, and the masters and that are forming Kubernetes cluster. So these are the 4 important components of Kubernetes master, which includes API server, scheduler, controller, and etcd. So coming to the Kubernetes worker node, as we discussed earlier, worker node can be any virtual machine or a physical server where containers are deployed. Every node in the Kubernetes cluster must run a container runtime such as Docker or Rocket. There are 2 other Kubernetes components also required for us to communicate with Kubernetes master, and they are kubelet and kubeproxy. So what are these kubelets and kubeproxy? First, let's take a look at the kubelet. The kubelet is a primary node agent that runs on each worker node inside the cluster. So the primary objective of this kubelet is it looks like the pod spec that was submitted to the API server on the Kubernetes master and ensures that containers described in that pod spec are running and healthy. In case if the kubelet notices any issues with the pods running on the worker nodes, then it tries to restart the pod on the same node. So in case if the issue is with the worker node itself, then in that case, Kubernetes master detects a node failure, then it tries to decides to recreate the pod on another healthy node. So it all depends on if the pod is controlled by a replica set or a replication controller. If none of them are behind this pod, then pod dies and will not be recreated on anywhere. So it is advised to use pod with a deployment or a replica set. Don't worry if you are not aware of all the deployment and replica set terminology. They are detailedly explained in the following videos. And next comes the kubeproxy. Kubeproxy is a critical element inside the Kubernetes cluster. It is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, across all the pods, and across all containers. And it also exposes services to the outside world. It essentially the core networking component inside the Kubernetes. So that's about the kubelet and kubeproxy. And now coming on to the pods and containers. So we have briefly discussed about pods and containers earlier in this video. But again, let's discuss it one more time. So pod is basically a scheduling unit in Kubernetes, just like VM in the VMware world. So each pod consists of one or more containers. In most cases, there will be one container. There are scenarios where you need to run two or more containers together inside a pod. In that case, one container can be helping the another container. So the primary advantage of pod is we can deploy multiple dependent containers together. So it acts as a wrapper around these containers. And we interact and manage these containers primarily through pod. So that's about the pods. Now moving on to the containers. I guess most of you are already familiar with it by now. It provides a runtime environment for applications. You can run containerized application processes inside these containers. As we discussed just a few minutes back, these containers resides inside the pod. Also remember that containers are designed to run microservices. It is not ideal for monolithic applications. So most importantly, Kubernetes supports Docker-based containers as well as Rocket-based containers. You might come across Docker-based containers quite often than others. So the four primary components inside the worker nodes are kubelet, kubeproxy, pod, and container. Besides that, there will be other add-ons such as C advisors and other plugins depending upon the requirement you have. So that's about the Kubernetes worker node and its components. So far we have seen the Kubernetes master and the Kubernetes worker node in two separate sections. And now let's combine these two. If you combine these two, this is what you get. The complete Kubernetes architecture cluster. As you can see, on the master node we have API server, scheduler, controller, and etcd. And on the client node, we have kubelet, kubeproxy, pods, and containers. In most cases, master node does not contain any containers. It just manages the workload on the worker nodes. And also, it makes sure the cluster of worker nodes are running healthy and successfully. In the above diagram, we are seeing only one worker node. But Kubernetes supports up to 5,000 worker nodes inside one cluster. So as you go deep into Kubernetes, these components will be part of our discussion very often. So for that reason, let's review all these components for one last time. Let's first review the components of Kubernetes master. They are API server, scheduler, control manager, and etcd. First, API server. So it's kind of a gatekeeper for entire cluster. In case if you want to create, update, delete, or even display any Kubernetes objects inside a Kubernetes cluster, it has to go through the API server. API server validates and configures the API objects that we submit. These API objects can be pods, services, replication controllers, deployments, or some more. So we interact primarily with API server using kubectl command. So that's about the API server. And next comes the scheduler. So scheduler is responsible for physically scheduling pods across multiple nodes. So depending upon the requirement that we submit to the API server, the scheduler will schedule pods accordingly. Next comes the control manager. Control manager is responsible for overall health of the entire cluster. It ensures that nodes inside the cluster are up and running and correct number of pods are running as mentioned in the spec file. And finally, we have etcd in master section. etcd is a central database to store current state of the cluster at any point of time. Your cluster information, nodes, secrets, controllers, and other objects configuration is stored inside the etcd database. Any component of Kubernetes can query the etcd to understand the state of the cluster. So this is going to be the single source of truth for all the components and the nodes inside the Kubernetes cluster. So these are 4 important components of Kubernetes master, which includes API server, scheduler, controller, and etcd. And now moving on to the worker node section. So coming to worker node section, we have a kubelet, kubeproxy, pods, and containers. First, kubelet. Kubelet looks at the pod spec that was submitted to the API server and ensures that containers described in that pod spec are running successfully and healthy. In case if kubelet notices any issues with those pods, then it tries to restart those pods on same node. In case if the issue is with node, master detects a node failure and launches the pods onto another healthy node. Next comes the kubeproxy. Kubeproxy is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, pods, and containers. And it also exposes services. Kubeproxy is essentially the core networking component of Kubernetes. After that, we have pods. Pod is basically a scheduling unit of Kubernetes. Each pod consists of one or more containers. In most cases, there will be one container. There are scenarios where you need to run 2 or more dependent containers together within a pod, where one container will be helping another container. So with the help of pods, we can deploy multiple dependent containers together. In Kubernetes, we primarily interact with pod than containers. Each pod has unique IP address inside the Kubernetes cluster. And finally, containers. Containers provide the runtime environment for applications. Containers will reside inside a pod. Containers consist of applications, libraries, and their dependencies. So that's about the Kubernetes worker node section. So these are some of the core important terminology that you want to remember. So that's about the Kubernetes architecture and its terminology. So before we move on to the next video, let's review the summary of what we have been discussing for over the last few minutes. So coming to the summary, first we looked at the very high level overview of Kubernetes architecture, where we discussed high level overview of architecture with some core components such as Kubernetes master, Kubernetes worker node, pods, and containers. Once we are comfortable with that, then we looked at the Kubernetes master node section in detail. In that, we discussed about 4 important components of Kubernetes master, which are API server, scheduler, controller, and etcd. After that, we discussed about the node section. In that, we discussed about 4 important core components of worker node, which are kubelet, kubeproxy, pod, and containers. After that, we combined these both master section and the worker node section to form the complete Kubernetes cluster. And finally, we reviewed the key terms we used in the master section and the worker node section. And now, this video leads to our next topic, which is installation methods of Kubernetes. In that video, we'll discuss what are the different ways you can install the Kubernetes. Then after, we have a demo for each of these, and link to that video is provided in the description below. And finally, thank you so much for watching this and hope to see you in the next video.